we'll take the next few minutes here and get set up so that we can have our first presentation, which will be from Maxime Visconte, who is the Director of IT for IFPEN, France's leading research institute on energy transition. And after a master's in engineering and chemical engineering and a few years in industry working as an advanced process control engineer, he is now in charge of facilitating data acquisition across labs and pilot scale industry units for IFPEN researchers. And so he's going to be talking about how open source projects have been made possible by the Creative Commons licensed ASM. And so we'll go ahead and get things set up there.
Let's dive right in. What does IFPEN wants to achieve with ASM? Two goals. First of all, I want to say all of you, internal efficiency. So we want our engineers to have larger data sets to train neural networks, to artificial intelligence, or everything you talked about earlier, and also be able to reuse the tools across the company. We have multiple labs doing the same thing, let's say GC, and they all developed their tools to deal with their data, their software, and it's wasted because the lab on the other side of the hallway doesn't choose the same software and cannot use their software for development. And so we want to encourage reusability of tools across the company, since now there's a lot of internal developers everywhere, to encourage that. And the second part, it is a bit more from IFPEN and specific to us. It's to be a key player in the energetical, environmental, and digital transition. So we are a public institute, and our mission is to change the world, let's say. So a couple of things. First of all, we want to facilitate the use of our experimental data. I talked about it in the last Allotrop Connect, why we're doing this, and how Allotrop allows us to do open data and comply with our obligations as a public institute. And we also want to facilitate the use of our tooling. So in order to achieve open data, we developed a lot of connectors to bring specific data, proprietary data, into Allotrop. And we thought, well, these tools we've been using, why not give them to the world, to society as a whole, to make science advance easier. So what's the use case? We have a lab A. They developed a web app to visualize and interpret infrared data. Okay, they have a software. It saves data as SPC files. So they developed an application that does this. We have a lab B, and they reach out to corporate IT, so myself, and they say, oh, I want a web app to visualize and interpret the infrared data. But they use a different software, and it uses JDX files. We could just modify the web app to read both data formats, and would be stuck when the third one comes in the pool and something. So what we decided, to push all of our infrared data to a data lake, and then have the web app read from the data lake. And the question comes, what is the correct format to put in the data lake? What should we use a SPC file? Should we use JDX files? And we chose to use ASM compliant JSON files. So instead of parsing files in the browser, so the users in the web app would parse on his computer and choose a file that would be parsed and locally. We ingest all of the ARIA data going back tens of years, and have it ingested in a Java pipeline. Couple issues with this. In order to read data and to parse proprietary data, we use open source algorithm. For example, we use open source algorithm, which means that if we are to publish our code, we are to use the GPL license they almost all use, which means and we could not do because of the ASM files that were proprietary from Allotrop. So we could either upload the code without the JSON schema files, which did not make a lot of sense because the library just can't compile without the schema files. So I discussed it with the team, with Corey, with Jamie, Ben, and me and others. And I was very, very pleased to hear about the open sourceification of these schema files. So two different ways to use ASM files. First, a license that is Creative Commons by NC, which means basically you can publish it on the web. You need to say who gave it to you. You can change it all you want, but you cannot use it commercially. So you cannot make money with it, with a big caveat, that is, in order to still be called ASM or Allotrop, you need to get approval from the foundation, but you can take the file, modify it all you want, just don't call it ASM file. It is very useful for me. And then you have the other license, which is CC by ND. So still say who gave it to you, so you have to acknowledge that the base file was from the Allotrop Foundation. You are not allowed to change it. You have to use it exactly as is. So you cannot make derivative files, but you can use it for commercial use. We're using both in our library. In the source code, we're using it under the NC license because I want to tweak the way the files are created. I want to be able to change properties just to make it work with Java, change spaces to tabs or to underscores, to avoid duplicates in sometimes older models, duplicates properties or stuff like this, just for internal use in the library. So I tweak it. It's not an Allotrop schema. It's a schema, an IFPEN schema derived from the ASM schema. However, during the export phase and in the binaries, what we distribute in the compiled form, you have the actual Allotrop file, and we distribute it under the CC by ND license, which means if you use our library, IFPEN's library, it is allowed in a commercial product. Given the license is still GPL derived, so it's the French version of GPL because the French government and whatever, but it's basically GPL. So you have to open your source code as well. So far, we have released 2 open source projects. So one that we call GC to ASM, which big surprise converts GC files to ASM. And another one that's called IR to ASM, which is a converter for IR files. So both of them are already usable. So we use them in production internally. Each of them has parsed already tens of thousands of files, and every night it parses all the files of the day before. The source code is available on GitHub. It's available on Maven to just use. It's production ready. We have many more new converters on the roadmap, and you can help. So it's open source. So far, it's just IFPEN, but feel free if you want to add say a new file support for infrared. Come in, open an issue, contribute some code. It would be our pleasure to build this together as a community. We have many more things on the roadmap. So for first semester, we're going to be working on NMR files. So we'll be working with a modeling group to revise the NMR schema, which is a bit outdated, and we're looking for a web service for serving Chromeleon enterprise data. So far we've only parsed files from let's say workstation installations, so software that is just installed on the lab machine without any corporate infrastructure. For Chromeleon, we are very committed to Chromeleon, so Thermo CMS. And we're using Chromeleon Enterprise, so everything is in corporate databases. And we felt that instead of re-exporting everything as files to parse the files, it would be better to attach something to our Chromeleon Enterprise. So we're going to be developing a web service with Chromeleon SDK to serve ASM data from our Chromeleon Enterprise data. And we'll be open sourcing this as well. Then maybe a quick demo to show how this works. So you have a ChemStation file that was just acquired. And I want to make an ASM compliant JSON file to use it after. The code is available again on our GitHub. So what I'm going to show today, you can reproduce at home if you want to. Let's go. So I have an example.d file. So you know, ChemStation file are not actual files. They're folders with many files inside. So I have an application.txt file in which I have some parameters. You see the formatting is a bit odd. So you have tab spaces. It's aligned, but machine readability is a bit awful. The units are hard to parse. The data itself is binary data. So if I open the data file from the detector, it's just gibberish. It's machine readable, sort of, but not human readable. And I want to make something of it. So I'm using our program. Okay, I want to say input file is example.d. My output file would be result. And the program generates a file that's called the result.json. It's the same data, but in a JSON format, where everything is human readable and machine readable. So I can say, okay, it's sample number 22465-1. What was it? When was it done? By whom? Injection time, and I can just put everything in my data lake. And then, as a researcher, as an engineer, if I want to train a data model, if I want, for example, to mix IR files with GC, the same sample, to mix its IR properties with GC properties and so on, I can just create a Python file. I won't be able to run it because I can run WebEx if I'm connected to the corporate network. But, just to show you how we do it. So everything is in a MongoDB database, and the client just types in a query. So I want to say, okay, gas chromatography aggregate document, and I want in the sample document, the sample identifier, everything that is 22 dash, etc. And I get the result as a JSON, and I can do everything I want in my code. And for if I am an engineer working to train a data model, at this point, I do not know and I do not care whether my data came from ChemStation, from Chromeleon, from the Shimadzu CDS, whose name I forgot, or Empower, or whatever. I can just take all the GC data from my lab, from other labs in the company, and from the IFPEN open data infrastructure. If I am a researcher and I want to use IFPEN data, I can as well, and then train my my model with this. So I hope it was interesting. I hope I've encouraged some applications to start and contribute. I know many of you internally have developed connectors. So I'm legally obligated to open it, so it's a bit easier for me than it is for you. But I hope we can share some more converters to make adoption easier. And I hope some of you will try and use it. Bring feedback, open issues on the GitHub, and make it better together. If you have any questions, mine, I'm done.
Great, thanks. Maxime.